I got 32 over 35.
Okay, let's see if we can, before the answer, I want the process. Okay, I want to know what you had to do here. Katie.
Well, first I multiplied 3 fourths by 4.
Okay, why? Yes, so you can get a common denominator. Now here's my question. Did you have to pick 10 and 14 as the two things that you multiplied, or was there maybe a little bit easier way to go? Matt. Why just 5 and 7? What are the factors of 14? 2 and 7. What are the factors of 10? 2 and 5. So why would you pick to multiply this one by a 5? Because it's the factor of 10 that is missing over here, isn't it? Okay, so you had to multiply numerator and denominator by a 5, making this 15 over 70 plus. And why did you choose to multiply this one by 7? Because it's missing the factor of 14, that's 7, right? So multiply numerator and denominator there by 7. Don't they now have the same denominators? Right? And so now it's 49/70ths. Now can you add them? Yeah, and? Yes. And did anybody reduce that? You can do it. See, I knew you could do it. The key to adding and subtracting rational expressions is what? What must you have? Raise your hand if you think you know what you have to have in order to add or subtract rational expressions. Brady. Yes, it's that common denominator. And the thing that I would recommend first is to factor your denominators. That way you can get the least common denominator. Now, would have multiplying the first one by 10 and the second one by 14, would that have worked? Yeah. What would have happened? You just would have had larger numbers, wouldn't you? Okay? You would have gotten there. You would have been able to reduce and get the right answer. But sometimes it's just a little bit easier if you pick the smaller factors to work with. So, you ready? For what? No. Sorry. Now, here's why I said don't use your calculator. Because on this next example that I'm going to show you, your calculator isn't going to do you a whole lot of good. Because look, these are rational expressions, meaning we're going to have all these expressions with x's in them. Binomials, polynomials. So we're going to do exactly the same thing that we just did, okay? What I would recommend doing first is factor all denominators. I would recommend that you factor all your denominators. Why? Do you remember what I did with the numbers? Remember how I factored them? What did it make finding very easy after they were factored? The least common denominator. It was pretty easy to see which factors were missing from one fraction to the next. So if we factor denominators, I think the same thing's going to happen here. So x squared plus 5x plus 4. Who's got this one? All right. Good. X plus 1 times the quantity x plus 4. Yep. Okay. Next one. Go ahead, Stephanie. Good. All right. Got that? Okay, so let's see if we can now state the LCD, the least common denominator. Well, we're of course going to need a factor of an x plus 1 and an x plus 4, aren't we? We need those two. Now look at your second fraction. Are there any other factors from that second fraction's denominator that are missing from our common denominator? Sarah? The 3, right? So I'm just going to put the 3 here. Okay. Let's do this. Let's multiply. Let's see, I'm going to say this. Multiply by missing factors. So each fraction has the LCD. All right. Fraction number 1. It's missing what factor? Who can tell me? Good, John. 3. Multiply top and bottom by 3. Second fraction is missing what factor? Sarah. All right, multiply numerator and denominator by x plus 4. Okay, does anybody have any questions on what I've done so far? You got it? Okay, so now I'm going to simplify my numerators. So let's see, I'm going to have 3 over my LCD plus, go ahead. Yeah, let's go ahead and multiply that out because I'm going to want to combine this here in a minute. There we go. Over all of this business. Okay. Denominator's the same? Are they? Yeah, isn't that what you were looking for? So if the denominators are the same, what can you do with numerators? Add them. All right. So number 5, add or subtract, depending on the problem, numerators. And I'm just going to rearrange it. Is everybody okay if I put it in standard form? Any questions with that? Yes. You mean right here? Because if you went ahead and factored and reduced that one, what you're going to end up with is this same fraction that you started at. 5x over 3 times the quantity x plus 1. And then these two would no longer have a common denominator, and then you would no longer be able to add them. Okay? Well, right, and that's a good question because that was going to be my next question. Trey? Absolutely. Okay? It's because you have all these, you have this up here as well that you would have to worry about. Okay? And so now when you combine them from here, now see if you can do any more factoring and reducing. Okay? Yeah, it's that 3 that doesn't allow you to cross off your x plus 4s. Okay? So that's what I put down for my step number 6 would be to factor and reduce. Well, does that numerator factor? Yeah, I don't think it does either, right? So if it doesn't factor, can it reduce? Nope. Because that's what you did last week on Friday, was the factoring and reducing. So there's your answer. Now, I'm hoping that you see the same the similarities between this problem and the problem that we did for that little warm-up with just the numbers. You want to get a common denominator. If it happens to not be the least common denominator, can you still do the problem? Well, yeah, it'll just be a little bit bigger, right? You'll have maybe instead of a x squared term on top, maybe an x cubed, but you can still work with it. Try to get the least common denominator, though. It will make your life a lot easier, I promise. All right, let's see here. No, that's not it. Here we go. Here's what I'd like for you to try. On page 517, number 1, then 11 through 21, the odds, and 12, and 35 through 39, the odds, and 40.